You are welcome to the free mark series for Jamb UTME 2026. Do not forget to obey the lecture protocol because I am not only giving you a must-repeat question in Jamb 2026, I am also giving you how to quickly solve them. As you are taking this lecture, if you are wise, if you are smart, ensure you have your pen and your paper. Take notes. As you are taking the lecture, continue to write what you understand because you are going to need that for subsequent revision. Do not forget to also enable full screen view in your device by tapping on the icon located around this place that I'm hovering my mouse to enjoy the maximum viewers experience for this lecture. Without wasting much of our time, let's quickly look at the Jamb repeated question 1. Jamb repeated question 1. This is a must repeat question. This question must come out in your Jamb UTME 2026. The question reads, which of the following substances absorbs moisture from the air and dissolves in it? Which of the following substances absorb moisture from the air and dissolve in it? A. Washing soda, which is the sodium triazocarbonate 4 decahydrate. B. Calcium chloride. C. Copper 2 tetrazosulfate 6 pentahydrate is the blue vitriol. D. Zinc chloride. What's the answer? Carefully look at the option A and option C. This is a hydrated form of this compound. How do you identify the hydrated form of a fluorescent compound? Using the chemical formula as we are seeing here, like A. To identify if this compound is a hydrated form or an anhydrous form, just look at this place. The hydrated form, they always put dots here. That's dots, period. But the anhydrous form always comes with a comma. Okay, you see a comma here instead of dots. So hydrated form, dots or period. Then anhydrous form, comma. Same with C, copper 2 tetrazosulfate 6 butahydrate. Can you see? Dots. This is a hydrated form of copper 2 tetrazosulfate 6. Before answering this question, let's understand the behavior of some chemical compound when they come in contact with water or when exposed to the atmosphere. Number 1, efflorescent substance. What are efflorescent substance? Substance that lose water of crystallization spontaneously when exposed to air. They lose water. Efflorescent substance are substances that they lose water to the environment. Once you expose them to the atmosphere, they lose water to the environment. And what kind of water do they lose to the environment? They lose their water of crystallization. What is the observation? They become powdery or dusty on the surface. So you notice that the substance become powdery or dusty in a way when it loses its water. And when it loses its water to the surrounding or to the atmosphere, it becomes an anhydrous form of the substance. And this anhydrous form has an appearance, a powdery appearance or a dusty surface. That's the anhydrous form. What is the reason for losing water to the environment? Why does a fluorescent substance lose water to the environment? So the water vapor pressure in the crystals of this compound is greater than the water vapor pressure of the air. Examples of efflorescent substances include sodium triazocarbonate 4 decahydrate or washing soda. Like I said before, how do you know using the chemical formula? How do you know that it is in the hydrated form or it's in the anhydrous form? When it's in the hydrated form, you see dots here or full stop or points. But when it's in the anhydrous form, this is replaced with a comma. You see a comma here instead of dots. Okay. The second example of a fluorescent substance is copper 2 tetrazosulfate 6 pentahydrate, which is the blue vitriol, and so on and so forth. Let's look at deliquescent. Number 2, deliquescent substances. What are deliquescent substances? Deliquescent substances are substances that absorbs moisture from the air and dissolves in it, forming a solution. When a deliquescent substance absorbs moisture from the air, it forms a solution. So, efflorescent substances lose moisture to the air, but deliquescent substances absorb moisture from the air and become a solution. They turn to a solution. That's it. They absorb moisture from the air and uses that moisture to form a solution. Take note of the keyword, forming a solution. What is the reason for deliquescence? What really happens when deliquescence occur? Water vapor pressure of the substance is less than water vapor pressure of the air. When the water vapor pressure of the substance is less than the water vapor pressure of the air, deliquescence occur. The substance absorbs moisture from the air. Moisture moves from the atmosphere into the substance. It's just a kind of diffusion gradient, a kind of diffusion balance on the external environment and in the internal environment, which is greater. That's what influences how this substance absorbs water or they lose water to the environment. And the examples of deliquescent substances include calcium chloride, sodium hydroxide, and potassium hydroxide. They all are deliquescent substances. They absorb moisture from the air and form a solution because the vapor pressure of the substance is less than the vapor pressure of the atmospheric air. Let's look at the uses of deliquescent substances. Uses of deliquescent substances. Number 1, drying agents. They are used as what? Drying agent or desiccants. If you buy some grocery products, you are going to see a substance in it that is packed in a paper material. You are going to see it is going to be labeled in it desiccants, or sometimes you can see silica gel. It is used to absorb moisture so that atmospheric moisture doesn't accumulate in that grocery product, that grocery item. Such an item might be easily destroyed by moisture. So they place these desiccants, these deliquescent substances in it to absorb atmospheric moisture to increase the shelf life or the lifespan of these grocery products. Another use of deliquescent substances is dust control. They absorb dust, okay? They control dust, they absorb dust. Another use of deliquescent substance is it is used in air condition and the windows of aircrafts. Deliquescent substances are used in air condition and the windows of aircrafts because they absorb moisture. You know, when aircraft goes up, they go higher up the altitude. So in that high altitude, there are lots of atmospheric moisture there. It has a high humidity up there. So you will need a deliquescent substance to absorb those moisture. Having understood the uses of deliquescent substances, let's look at hygroscopic substances next. Number 3, hygroscopic substances. What are hygroscopic substances? They are substances that absorb moisture from the air, but do not necessarily dissolve in it, but they become moist or sticky. This is the little difference between deliquescent substances and hygroscopic substances. Deliquescent substances absorb this moisture from the air and they turn to solutions. But the hygroscopic substances absorb moisture from the air, but they become sticky. They don't turn to solutions. They become sticky. A solution is not formed. So let's look at the examples of hygroscopic substances. They include zinc chloride, which is whitish in color, hydrogen tetraososulfate 6 acid, which is also known as the sulfuric acid, magnesium chloride, and quicklime, which is the calcium oxide. These are hygroscopic substances. Let's quickly look at the uses of hygroscopic substances. Uses of hygroscopic substances. Number 1, as drying agents. They are also used as desiccants. So why will hygroscopic substance be chosen over deliquescent substance? Remember their property. Hygroscopic substance does not form a solution. They become sticky after absorbing moisture from the environment. So one might choose hygroscopic substance over deliquescent substance because if the place that the drying agent is need to be used needs to be dried, moisture is not needed. Any percent of moisture is not needed. And extreme dryness is required. So moisture is not needed. So hygroscopic substance might be chosen as the appropriate compound for such function. The second use of hygroscopic substance is dust control. They are used as dust control, just like the deliquescent substances. The third use of hygroscopic substances is used in air condition and the windows of aircraft. So they are used equally, both deliquescent substance and hygroscopic substances. They are used equally. But the difference is that hygroscopic substances might be chosen over deliquescent substances if any percentage of moisture cannot be tolerated. So when the area is needed to be dried as much as possible, or all the moisture in that environment or that area is needed to be absorbed as much as possible, hygroscopic substance is deemed fit or appropriate for such purpose. Note something very important. They are preferred over deliquescent substance where the change in the state of matter, solid to liquid, is avoided. So when we don't need liquid, like I earlier explained, when you don't need liquid in the area that you are using it to dry, when liquid is not tolerated, any amount of liquid is not tolerated, they are choosing over the deliquescent substance. Let's quickly look at a summary table of what we have just discussed. The summary table says on the left hand side, the very first column, we have the property, and in the middle, we have the effect in air. Then on the right end of the table, we have the examples. Looking at the left hand side, we have the property, and under efflorescence, the effect in air, it loses water and becomes powdery. Examples of efflorescent substance include sodium triisocarbonate 4 decahydrate and copper 2 tetraososulfate 6. Moving to the left hand side of the table, the next we have there is deliquescent. And what is deliquescence? They absorb water from the environment and dissolve in it. And when they dissolve, they do what? They form solution. And examples of deliquescent substances include calcium chloride, sodium hydroxide, and potassium hydroxide. Moving to the left-hand side of the table, we have the hygroscopic substance as the next. And hygroscopic substance, they absorb moisture from the air. That's the effect in air. And they become what? Damp. They become sticky. They become damp. Like the feel of when you use your towel to pat your body dry after beating. They become damp. And examples of hygroscopic substances include zinc chloride, hydrogen tetraososulfate 6 acid or sulfuric acid, and magnesium chloride. Let's go back to the Jamb repeated question 1. Here is the question. It says, which of the following substances absorb moisture from the air and dissolve in it? Which of the following substances absorb moisture from the air and dissolves in it? A. Sodium triisocarbonate 4 decahydrate, which is washing soda. B. Calcium chloride. C. Copper 2 tetraososulfate 6 pentahydrate, which is the blue vitriol. D. Zinc chloride. What's your answer? You answered right. D is not the answer. Zinc chloride is not the answer. Zinc chloride is a hygroscopic substance. C, which is copper 2 tetraososulfate 6 pentahydrate, which is the blue vitriol, is not the answer. A is not the answer because sodium triisocarbonate 4 decahydrate, washing soda, does not absorb moisture from the air. It's an efflorescent substance. It loses water to the air. All for your answer. B. Calcium chloride, which is a deliquescent substance. What does it do? When exposed to air, they absorb moisture from the atmosphere and they turn to a solution. As a result of the moisture they absorb from the environment, they dissolve in the moisture and turns to a solution. Let's move over to the Jamb repeated question 2. Jamb repeated question 2. Take a look at the chemical equation above. The question says, in the reaction above, which statement correctly identifies what is oxidized and what is reduced? A. Iron 2 tetraisosulfate 6 is reduced to iron 3 tetraisosulfate 6, while potassium tetraisomanganate 7 is oxidized to manganese tetraisosulfate 6. B. Iron 2 tetraisosulfate 6 is oxidized to iron 3 tetraisosulfate 6, while potassium tetraisomanganate 7 is reduced to manganese tetraisosulfate 6. C. Iron 2 tetraisosulfate 6 is oxidized to potassium tetraisosulfate 6, while potassium tetraisomanganate 7 is reduced to water. D. Potassium tetraisomanganate 7 is reduced to potassium tetraisosulfate 6, while iron 2 tetraisosulfate 6 is oxidized to manganese tetraisosulfate 6. What's the answer? So before answering this question, we have to understand what oxidation and reduction is. Understand a redox reaction, what a redox reaction is. Understand what an oxidizing agent and a reducing agent is. Not only understanding them, but how to identify them in a chemical equation. Oxidation. Take note of the color coding, red. Oxidation can mean any of the following. The first meaning, it can mean the addition of oxygen. Take note. The second meaning, it can mean the removal of hydrogen. Take note. The third meaning, it can mean the loss of electrons, which is the oil acronym. Oxidation is loss, that's the oil acronym. Oxidation is loss, electron is loss. Then the fourth, it can also mean the increase in oxidation number. Take note of these four features of oxidation. Addition of oxygen, removal of hydrogen, loss of electron, which is the oil, increase in oxidation number, according to the observation. Let's see examples next. Examples of oxidation. The first oxidation example we have here is iron. Iron loses 2 electrons to form what? Iron 2 ion. This 2 you are seeing here signifies the electron loss. This E you are seeing here signifies electron. Then this minus you are seeing here means something left, loss, minus, loss, left. If it was gain now or reduction, you are going to see plus here. But this is oxidation, which is loss of electron. So that's why you are seeing minus here. So electron loss. Iron loses 2 electrons to form iron 2 ion. The second example we have here is the addition of oxygen. Hydrogen is an electropositive element. So addition of oxygen, when hydrogen reacts with oxygen, it forms water. Can you see? Addition of oxygen is also oxidation. Remember, we also have 2 other features of oxidation. Note something very important. Oxidation is also the addition of negative electrons. Remember, hydrogen is a non-metal but is electropositive by nature. So excluding hydrogen, because hydrogen is electropositive in nature. So hydrogen is not among. It doesn't comply with this law. It doesn't go in accordance with this law. So oxidation is also the addition of electronegative substance. So when you look at this equation we have here, this second equation we have here, oxygen was added to hydrogen. And oxygen is an electronegative substance. So what just occurred here is an oxidation reaction. With this, we have come to the end of oxidation. Let's look at reduction. Reduction, take note of the color coding, green. What is reduction? Reduction is the direct opposite of oxidation. Direct opposite of oxidation, that's reduction. Oxidation is the direct opposite of reduction, while reduction is also the direct opposite of oxidation, vice versa. And what are the features of oxidation? We have no time for definition. Learn the features and use the features to derive your own definition. The first feature of reduction we have here is removal of oxygen. Remember, oxidation is addition of oxygen, reduction is removal of oxygen. So in oxidation, oxygen is going in, but in reduction, oxygen is going out. The second feature we have here is addition of hydrogen. Remember, in oxidation is removal of hydrogen, but in reduction, we are adding hydrogen. Hydrogen is added. The third feature we have here is gain of electron, which is the ROIG. In oxidation is oil, but in reduction is Rig. Oxidation oil, which is oxidation is loss. Then reduction is Rig, which is reduction is gain. Then the fourth feature we have here is decrease in oxidation number. During oxidation number increases. But when reduction occurs, oxidation number decreases. Let's look at examples next. Examples of reduction. The first equation we have here is copper 2 ion getting reduced to copper metal, which is what? Gain of electron. It gains electron to form copper metal. The second example we have here is hydrogen is added to copper oxide, which is solid, to form copper metal. Remember, in reduction, oxidation number reduces. Copper oxide got reduced to copper metal, while hydrogen got oxidized to what? To water. So in this reaction, what occurred here? Loss of oxygen. So oxygen was lost, so copper oxide turned to copper metal, which is a reduction reaction. Note something very important here about reduction. Reduction is also the removal of negative electron, excluding hydrogen, just like oxidation, the removal of negative electron. So oxidation is the addition of negative electron, excluding hydrogen, but reduction is the removal of negative electrons, excluding hydrogen. So you know the electropositive elements, okay? They are the metals and hydrogen, while the electronegative elements are non-metals. Let's understand and know how to identify oxidizing agents and reducing agents. Reducing and oxidizing agents. What are oxidizing agents and what are reducing agents? Oxidizing agents, the substance that gains electron, gets reduced. So an oxidizing agent is a substance that gains electron. And as it gains that electron, it gets reduced in the process. So in the process of acting as an oxidizing agent, the substance gets reduced. What is reducing agent? Reducing agent is the substance that loses electron and gets oxidized. So reducing agent loses electron during the reaction and gets oxidized. In its process of acting as a reducing agent, it gets oxidized in the reaction. Now let's understand what I want you to take note of something very important. I just remember. So include it in your notes. When an oxidizing agent comes in contact with a stronger oxidizing agent, that oxidizing agent turns to a reducing agent. Likewise, when a reducing agent comes in contact with a stronger reducing agent, it turns to an oxidizing agent. So it all boils down to the oxidizing and reducing potential of the element or the compound that determines if it's going to act as an oxidizing agent or if it's going to act as a reducing agent. Because you might know a chemical compound as an oxidizing agent, but some reaction that you see them, when you encounter them in some question, especially question in Jamb, UTME, and WAEC, they might not be acting as an oxidizing agent in that question. Immediately, such a substance comes in contact with a stronger substance of the same property, it steps down for the substance to take over. What is a redox reaction? A redox reaction is any reaction that involves the transfer of electron. That's the redox reaction. So oxidation reaction is a redox reaction. Reduction reaction is a redox reaction. So provided there is a transfer of electron, either electron gain or electron loss, that is known as a redox reaction. The bottom line is that oxidation and reduction occurs in a redox reaction. Now that we have understood what oxidation, reduction, oxidizing agents, and reducing agents are, let's go back to the Jamb repeated question 2. The question reads, in the reaction above, which statement correctly identifies what is oxidized and what is reduced? These are the options A to D. Remember, there is no one pattern of answering or solving questions from oxidizing agent and questions from reducing agent. There is no one pattern of solving them in examination. As a substance might act as an oxidizing agent in this chemical reaction, and in another reaction, you find that substance acting as a reducing agent. So you have to study the reaction and ascertain the oxidizing and the reducing agents in the reaction. When you take a look at this reaction, it's a redox reaction because electrons are transferred. So when you take a look at the left-hand side of this chemical reaction, we have iron 2 tetrazosulfate 6 acid plus potassium tetrazomanganate 7, and we have concentrated tetrazosulfate 6 acid. When you look at the right-hand side of the reaction, we have iron 3 tetrazosulfate 6. And on the left-hand side of this reaction, we have iron 2 tetrazosulfate 6. During oxidation, oxidation number increases, and that has given us a clue that the oxidation number of iron that was 2 here is now 3 here. So that tells us that this is an oxidation reaction. So let's figure out the oxidizing agent first before we figure out the reducing agent. So oxidation occurred here, yes, and reduction also occurred simultaneously. Okay, so the big question now is which of these chemical compounds among these three, 1, 2, 3, is the oxidizing agent here? Iron 2 tetraoxosulfate 6 is the reducing agent. So what was oxidized and what was reduced? Okay, since we already know the reducing agent, which is iron 2 tetraoxosulfate 6, remember, when a reducing agent reduces a substance or take part in a reduction reaction, the substance itself gets oxidized. So that tells us that this reducing agent, iron 2 tetraoxosulfate 6, was oxidized in this reaction to form iron 3 tetraoxosulfate 6. So we now know the substance that was oxidized. So which of the chemical compounds here was reduced in this reaction? Potassium tetrazomanganate 7 oxidized iron 2 tetraoxosulfate 6 to form iron 3 tetraoxosulfate 6. And this potassium tetraoxomanganate 7 itself got reduced in the process to what? Manganese tetraoxosulfate 6. So D is not the answer because potassium tetraoxosulfate 6 is not even in the reaction. C is not the answer because potassium tetraoxosulfate 6 is not in the reaction. A is not the answer because iron 2 tetraoxosulfate 6 acid is not reduced. During oxidation, the oxidation number increases. You can see that iron 2 tetraoxosulfate 6 here turned to iron 3 tetraoxosulfate 6 here. That tells you that it was oxidized to form this. Or for the correct option, which is B, iron 2 tetraoxosulfate 6 is oxidized to iron 3 tetraoxosulfate 6, while potassium tetraoxomanganate 7 is reduced to manganese tetraoxosulfate 6. Congratulations on earning your 1 mark in Jamb UTME 2026 Chemistry.